Hi everyone, I hope you are fine. Welcome to a new tutorial. In this video, we'll discuss the soil's materials. Let's go. Okay, soil materials. We have two types of soil. We have natural soil and unnatural soil. Natural soils are the fragile or fragmented surface layer that covers the surface of the earth. The soil consists of fragmented rock materials that were previously subject to change because of their exposure to environmental, biological, and chemical agents, including weathering and erosion factors. Number 2, unnatural soil. Abnormal soil are formed and created abnormally by human beings, formed and combined in factories, according to the specifications required for a particular purposes. Type of soils material. Natural soil materials include existing materials, formation, excavation, backfilling, embankment, fill, embankment, load bearing or subgrade. Unnatural soil materials include granular subbase, recycled crushed aggregate subbase, coarse and base coarse, pervious backfill aggregate, crushed bedding sand, jointing sand. Slide number 4. We have soil classification as per AASHTO. AASHTO is American Association of State Highway and Transportation Officials. AASHTO classification system, and also we have another system to classification the soils. It is USGS system, Unified Soil Classification System. By the way, this chart is very important to know as material inspector or as lab technician. General classification divided by two main columns: granular soil materials and silt and clay materials. Granular soil materials, 35% or less passing through the sieve number 200. The size of sieve number 200 is 0.075 millimeter, and more than 35% passing through the sieve number 200, it's called silt clay materials. Okay, we will discuss this table from the beginning. We will discuss classification of the soil through the Atterberg limit, and we have soil gradation. Both of them mean soil classification. Okay, we will see particle size definition. We have grain size, boulder, couples, gravels, divided to coarse gravel, medium gravel, fine gravel. Also we have sand, coarse sand and fine sand. Also we have silt and clay. The boundary between boulders and cobbles, and the boundary between cobbles and gravel, it's sieve with size 75 millimeters, that means 3 inches. And the boundaries between gravel and sand, it's sieve number 10, the size is 2 millimeter. And the sand and the boundaries between coarse sand and fine sand, it's the sieve number 40. and the boundaries between the sand and silt and clay, it's the sieve number 200. This the sieve is very important. The size is 0.075 millimeter. Also, the boundaries between silt and clay is 0.002 millimeters. In H2, divide the silt and clay according to plasticity index BI. The plasticity index in this chart, more than 10, it's clayey, and if the plasticity index less than 10, it's silty soils. Okay. Plastic limit equal liquid limit minus plasticity index. Plastic limit, if plastic limits less than 30%, it is A76, and if plastic limit more than 30%, it's A75. Okay. Here we have granular soil materials include A1 type, A1 divided to A1A, A1B, and A3 and A2 divided A24, A25, A26, A27. All these excellent to good material. A1 stone, fragmented, gravel and sand, A3 fine sand, A2 silty and clayey gravel sand. Also we have silt and clay materials include divided to A4, A5, A6, A75, A76. A4, A5 silty soils and A6, A7 clayey soils. This is a fair to good. Okay, very good. Suitable material that used in roadway section. Suitable material taken from the roadway excavation embankment material shall consist of granular materials free of excess moisture and other unsuitable material conforming to the following. Number 1, maximum practical size not to exceed 1/3 of placement layer thickness. Number 2, materials shall be classified according to H2 M145 in general. Suitable materials shall meet soil classification A1, A2 or A24. A1, A2 and A24. Number 3, material that can be compacted to 95% to the maximum density as required in article section 2.534. Number 4, material shall have a maximum plasticity index of 6 and a soaked CBR after 4 days soaking is not less than 10% for formation and not less than 30% for impactment when compacted to 95% of maximum dry density. Suitability test including material gradation, plasticity and CBR tests shall be done in accordance with table 212. All suitability testing will be done with one test each per 3000 meter per square for existing materials and 1000 meter per square of embankment materials. We have traffic pavement and pedestrian pavement. Traffic pavement, top 300 millimeter of the roadway embankment at the subgrade level shall be constructed into layers of 150 millimeter each of embankment material meeting the requirements of section. Okay, very good. Where traffic pavement is placed on existing ground or on existing subgrade, the existing material shall be scarify it and recompact it in accordance with article of section. Okay, it shall have a minimum CBR. CBR it is California bearing ratio of 10% when compacted to 90% of maximum dry density and minimum CBR of 30% at a compaction of 95% of maximum dry density. If the CBR of the existing material is less than 10%, then the top of 300 mm depth shall be removed and replaced with load-bearing material compacted to a minimum density 95% with a California bearing ratio of 30%. Pedestrian pavement, top 150 mm of roadway embankment under pedestrian pavement at the subgrade level shall be compacted to a minimum density percent of a maximum dry density 95% with a California bearing ratio of 25%. And additional working layers of aggregate material may be placed on top of the compacted embankment. Okay, very good. This is trail sampling for existing material formation. Trail sampling for excavation material backfilling. Trail sampling for embankment, trail sampling for embankment. The part 2 is unnatural soil material. Trail sampling for subbase. Granular subbase material shall consist of hard, durable, natural, screened gravel or crushed stone and shall be free from clay balls or other deleterious substances. Granular subbase type 1 shall be used under footpath and type 2 under roads. Granular subbase shall be well graded and lie within the grading envelope shown in table 3.3 when tested in accordance. One sample every 1,000 meter per square or part of as directed by the engineer shall be tested for grading plasticity index, maximum dry density CBR and loss by abrasion. 3 in situ density test be made every until of granular subbase laid 1 until being 300 meter or as directed by the engineer. Materials shall meet the minimum required per the testing standard listed in table 3.4. Okay, very good. Granular subbase gradation, sieve, percentage, passing. This is type 1 for under footpath and type 2 is under roads. Very good. Slide number 14. Granular subbase test requirements. We need this test sampling Los Angeles application sampling stand equivalent liquid limit plasticity index compaction test dry density moisture content test particle size sieve analysis of fine and coarse aggregate CBR at 98% of maximum dry density. Trail sampling for recycled crush base coarse and subbase. Okay, crushed concrete aggregates shall consist of clean, hard, durable, angular fragments of rock, concrete and sand fragments of uniform quality complying with the general requirements specification. Okay, very good. Here, all RCA for base course shall consist of crushed rock, crushed concrete, stone fragments, including sand. RCA is recycled crushed aggregate base course. This is recycle crushed aggregate. RCA base gradation, sieve percentage passing. RCA base testing requirements, loss by vibration test, liquid limit elasticity index, sand equivalent, CPR, soundness, flatness index, elongation, sulfate content, chloride content. Very good. Slide number 19, trail sampling for pervious backfilling. The pervious material shall be clean, hard, durable, sand, gravel, or crushed stone, free from organic material, clay balls, or other deleterious substance. The type of pervious material shall be as indicated on the drawing or in the particular specification or in the bill of quantities (BOQ). Pervious backfill material shall be clean, hard, durable sand, gravel, or crushed stone, free from organic materials. Slide number 20. Okay, very good. These are pervious backfill. Slide 21. Very good. Slide 22, percentage of passing, standard sieve size, type 1, type 2, type 3, type 4, type 5, type 6. Slide 23, trail sampling crushed bedding sand. Layers of uncompacted sand shall be screeded to a depth 50 millimeters over the compacted subbase. This layer of bedding sand shall be used for leveling. The installation of interlocking concrete pavers shall comply with the requirements specified herein and elsewhere in these specifications. Okay, very good. The subgrade and aggregate base course for polystyrene and vehicular concrete paving blocks shall be prepared as per particular specifications and contract documents as applicable. Moreover, in absence of these documents, the subgrade shall follow ASTM or ASHTO or EN standard. Slide 24. Here crushed bedding sand and black sand. Okay, slide 25. Grading of bedding sand, sieve percentage of passing. Slide 26. Trail sampling for jointing sand. The joints in the paving blocks shall be filled with sand complying PS 7533, so on, by sweeping in the jointing sand unless otherwise approved by project owner. The grading limits for the jointing sand specified in PS 7533 are indicated in the table below. Interlocking concrete paving blocks should be tamed with a mechanical plate vibrator equipped with a rubber pad on the tamping face to minimize damage to the finished surface and appearance of the paving blocks. Slide 27. This is jointing sand. Okay, grading for jointing sand, sieve, percentage passing. Quartering sample. Okay, by these tools. These are refill books to divide our samples. Slide 30. Here is the woven. Okay, sieve analysis. We're doing this test to know the type of our soil, if it's sand or gravel or silt or clay. We use sieves and this is sieve number 10, number 40, and so on. We need oven 110 degrees to 105 degree. Also we need balance and refill box divided as we see before, and we need wire brush and hair brush. Also we need mechanic vibrator. Here, this table sieve, millimeter, retained weight per gram, retained weight, percentage, passing, percentage, very good. Here, passing percentage, grading sieves. Slide 37, Proctor or compaction test. The process of removing voids from the soils by improving its properties and increasing its tolerance. We have two types of Proctor or compaction test: standard compaction test and modified compaction test. The standard compaction test, we have 3 layers and 27 blows in each layers. But in modified compaction test, we have 5 layers and 56 blows for each layers. The target of this test, Proctor test or compaction test, maximum dry density, MDD, and optimum moisture content, OMC. The tools, compaction mold, our tools, compaction mold and compaction mold here, compaction mold, this, and hammer, compaction hammer, and also we need woven 105 degrees to 110 degrees, and also we need balance and tray and graduated cylinder for measuring water added to soil. Slide 39. Okay, slide 40. Test number, percentage of water added, weight of wet soil plus mold, weight of mold, weight of wet soil, bulk density, number of weight of container, weight of wet soil, and so on. Here optimum moisture content, OMC, percentage, maximum dry density, MDD, gram per cc. Slide 40N, water content, percentage, and dry density, gram per cc. Okay, slide 42, CBR or California bearing ratio. In this test is determined by plotting the relationship between the load required to penetrate the soil at a constant rate and the value of this penetration. Tools we used: CBR machine, CBR machine. Here this CBR machine and CBR mold. CBR mold. CBR mold, 15.2 centimeter height and 17.8 centimeter. CBR mold with 15.2 centimeter diameter and 17.8 height. Compaction hammer like this here, 4.5 kilogram. Also, we need round disc with 2.25 round disc with 2.25 kilogram weight and 15 centimeter diameter. Okay, very good. Also, we need blotting meter and sample immersion basin like this for to soaking our samples, and we need balance. Here dry density for CBR samples, number of blowns, weight of mold plus soil, weight of mold, weight of soil, weight of mold, density, and so on. Very good. Here time, corresponding penetration, millimeter, Dale reading, load kilogram per centimeter per square, 10 plows, Dale reading, 30 plows, and so on. Slide 49, moisture content after soaking, container number, weight of weight soil container, weight of dry soil both container, weight of container, weight of water content. Slide 50. In this chart we have penetration by millimeter and stress on piston, kilogram per centimeter per square. Slide 51. In this chart we have dry density, gram per centimeter per square, and corrected CBR percentage. Slide 52. We have Atterberg limits. Atterberg limits divided to solid soils, solid state, and semi-solid state. Between two types we have shrinkage limit, and we have plastic state, and we have plastic limit, and we have liquid state, and we have liquid limit. This is the direction of increase in moisture content. Slide 53, liquid limit. It is less moisture content soil can be in a state of fluidity. If it's less, the soil becomes plastic. Slide 45, we have Desagrange method. Okay, Desagrange method. The tools, this is the machine here. We need metal bowl, and standard slotting tool, and 10 millimeter thickness of glass. And also we need distilled water bottle and airtight container and laboratory moisture content meter and drying oven and balance. On this chart, number of blows, and here moisture content. Plastic limit, BL, it is the water content of the soil which, if it is less than, the soil becomes non-spandex. Slide 57. Here the machine of Casagrande method. This is the glass plate. Slide 58. Liquid limit, plastic limit, container number, weight of wet soil container, weight of wet dry soil container, and so on. Here plasticity index equal liquid limit minus plastic limit. Okay, very good. Also we have sand equivalent test. The principle of the sand equivalent test is basically based on taking a quantity of sand and separating it from very fine grain. Slide number 60. Okay, very good. Slide 61. Here is the sand equivalent test. Slide 62. Sand equivalent test also. 63. Sand equivalent value equal sand reading divided by clay reading. Slide 64. We have field density test in situ or FDT test. This test is very important because it determines the strength and quality of earth and backfill. Okay, this is a sand cone. This is a field density test. Yes, very good. Sand cone method. We use this method called sand cone method. Sand cone method, the tools, our tools in this method is sand cone machine, the blade with circle in the middle here, and drilling, and we need also drilling tools, and we need standard sand. Standard sand passing from sieve boiling 6000 millimeter and retain in sieve boiling 300 millimeter. And also we need screws for fixing the tray, and we need balance to 15 kilogram, and also we need roofing, and also we need container for moisture content MC. Very good. Finally, calculate compaction percentage equal dry sand density divided by dry density in the lab multiply 100. Mass of sand to fill cone only, bulk density of sand, MDD, optimum moisture content. In upcoming videos, we will see full detail of all these tests. Thank you for watching. Stay safe.